Welcome back to another episode of Math with Dr. War. In today's lesson, we're going to look at LCM and GCF word problems. These are basic mathematics topics on the GED exam, and you cannot use a calculator. In a previous video, I showed the mechanics of using the ladder method to find LCM and GCF. Now, because these are word problems, you're going to have to figure out whether your problem is LCM, least common multiple, or GCF, greatest common factor. Sometimes in a word problem, they're going to say, find the least common multiple, or greatest common factor. But that is very rare. So let's take a look at some keywords and phrases that will help you identify what type of problem you are dealing with. Now, if you have a least common multiple problem, you're going to know by keywords and phrases. If the situation is occurring or happening again and again, and the keyword here at the same time, it is LCM. The L in LCM represents least. So if you see the word least or smallest or minimum, that tells you you're dealing with LCM. Also, if you see the word first or next. In your problem, if the situation is repeating over and over, meaning that it's cyclic, is LCM. If you have multiple items, LCM. When both will meet again, or when both will be equal, that signifies you have LCM. Greatest common factor, remember the F, which means factor, means divide. Therefore, if you're splitting or sharing anything, it is GCF. If you're dividing or cutting into pieces where you have no leftovers, that is GCF. You also know GCF if you're arranging anything into groups or you're trying to figure out how many people to invite. Again, the G in GCF stands for greatest. Therefore, if you see the word greatest or largest or maximum, those are your key words that you're looking at a greatest common factor problem. Let's look at some examples. In the first few problems, we're not going to solve. We just want to identify whether you have an LCM or GCF word problem. So the first question says, Kyle has 120 crayons and 30 pieces of paper to give to his friends at a party. What is the largest number of friends he can have at the party so that each get equal number of crayons and equal number of paper? Now, because I saw the word largest, I know that that goes with greatest, so this is a GCF. Also, because they wanted everyone to get equal numbers where nothing is left over, was also a clue that we're dealing with GCF. Rosa is making a game board that is 20 inches by 65 inches. She wants to use square tiles. What is the largest tile she can use? Because they said largest, that is your clue. You're dealing with GCF. A radio station gave away a $100 bill for every 100th caller. Every 30th caller received free concert tickets. How many callers must get through before one of them receives both a coupon and a concert ticket? Now, because they said both, that is my keyword that this is LCM. Another keyword for me is every. I notice every time I see this every in my word problem, it goes with LCM. Two bikers are riding a circular path. The first rider completes a round. The second rider completes a round in 18 minutes. If they both started at the same place and time and go in the same direction, how many minutes will they meet again at the starting point? So because we want to know after how many minutes will they meet again at the starting point is our clue that we're dealing with LCM. Now let's look at some multiple choice questions to see if we can figure out whether our problem is LCM or GCF and choose the correct answer. So the first one we have here, it says a local readers club has a set of 12 hardback books and a set of 18 paperback books and a set of 36 magazines. Each set can be divided equally among the club members. Now, because I see that word divided equally, that is a clue that I'm dealing with GCF. If I go on to the question, notice it's saying, what is the greatest possible number of club members? So we're finding GCF. The numbers we're dealing with is 12, 36, and 18. And I did not write them in order. Using the ladder method, the smallest prime number to divide these three is 2, which leaves me with 6. Now half of 36 is 18, and half of 18 is 9. 6, 18, and 9 are all divisible by 3. 3 goes into 6 2 times, 3 goes into 18 6 times, and 3 goes into 9 3 times. We have 2, 6, and 3. There's no number here that would divide them evenly because, again, we want to divide evenly. So we're finished. And always remember that when it is your GCF, we're just looking at the outside here. So we'll multiply 2 times 3, and that would give us 6. So my answer is B, 6 members. Let's try that again. An electric device beeps every 21 seconds. Another beeps every 28 seconds. If they both start beeping at the same time, and I see that word same time, notice I see that word every right here. How many seconds will it be before the next, that's another keyword, next time they beep together? Now, all of these words indicate that this is going to be an LCM. The numbers we're dealing with is 21 and 28. The smallest prime number that would divide 21 and 28 is 7. 7 goes into 21 3 times. 7 goes into 28 4 times. Now, the only number that would divide 3 and 4 evenly is 1. And because we're finding the LCM, we have to make that L. There it is, where we're multiplying 7 times 3 times 4. 7 times 3 is 21. And then if I take that and multiply it by 4, 4 times 1 is 4. Since I got that 4, I'm looking, there's only one 4 here. So my answer is 84 seconds. If you want to continue, you can go 4 times 2 is 8 to get the 84. But once I did 4 times 1 and got that 4, I was finished. Remember, your test is timed. Buses from 2 different bus routes each stop at the same corner. Let's get my green. The same corner at 9 a.m. Buses from one route stop at that corner every 9 minutes. Buses from the other route stop there every 12 minutes. What is the fewest numbers of minutes that will pass until the next time buses from both routes are at the corner at the same time? We have so many keywords here. We see the word same, we see the word every, fewest, next, both. All of that signals LCM. So we're looking at the time because they want to know fewest number of minutes. So we have 9 minutes and we have 12 minutes. And we have to find the LCM. Smallest number to divide 9 and 12 is 3. 3 goes into 9 3 times. 3 goes into 12 4 times. 3 and 4, the only number to divide them evenly is 1. So we're finished. we're going to make our L because we're doing LCM. So we're doing 3 times 3 is 9. 9 times 4, 36. So our answer is B. At the beginning of the school year, the principal at Adams Middle School equally divided each of the following items among the new teachers. Now, once I see the word equally divided, I'm like, this has to be GCF, but I'm going to keep reading. 48 red pens, 40 whiteboard markers, 16 whiteboard erasers. There were no items remaining. Another key word, no items remaining. GCF, no leftovers. Then the question states, what is the maximum? Again, maximum greatest possible number of new teachers at Adams Middle School at the beginning of the school year. All of these are keywords for GCF. So we're finding the GCF of 48, 40, 16. All of these are even, so I'm going to divide by 2. Half of 48 is 24. Half of 40 is 20, and half of 16 is 8. They're still even, so we're going to divide by 2 again. Half of 24 is 12. Half of 20 is 10. Half of 8 is 4. They're still even, so we're going to divide by 2 again. Half of 12 is 6. Half of 10 is 5. Half of 4 is 2. Now I have 6, 5, and 2. The only number that can divide them evenly is 1, because remember I'm finding the GCF. So we just need the outside. Because with GCF, everything has to be all the numbers. So there are 3 numbers. You got to be able to divide all 3 numbers evenly. So we're multiplying 2 times 2 is 4, and 4 times 2 is 8. Our GCF is 8. The last two, Devin plans to display his entire collection of 128 arrowheads. He wants to display an equal number of arrowheads in each of several different cases. So notice you're going to have different cases, several different cases, but they must be equal. Now it says here, which could not be the number of arrowheads Devin could display in each case. Now because they said equal numbers means you are dividing. Whenever you're dividing, we know that's GCF. Now notice they only gave us one number. So you're like, one number. So which means the number here, one of these, cannot divide 128 evenly. And that number would be our answer. So let's begin dividing. Can 8 divide 128 evenly? 8 goes into 12 one time, which leaves us with 8. Subtract, I get 4. Bring down the 8. And 8 goes into 48 6 times. Let's take 128 and divide it by 12. 12 goes into 12 one time. 1 times 12 is 12. When you subtract, you get 0. Bring down the 8. Now we know 12 can't go into 8. So notice here we have a remainder. So which could not be the number of arrowheads Devin could display in each case? Our answer is B, 12. This did not divide evenly. Last one. Christina takes out the trash every 3 days. Now, here's our favorite word, every 3 days. She cleans her room every 4 days. She feeds her pet turtle every 6 days. Christina took out the trash, cleaned her room, and fed her pet turtle today. In exactly how many days will she do all 3 of these tasks again on the same day? So she's doing these multiple tasks. Now, every and same tells me LCM. So we have 3 because they want to know how many days. So we're looking with the 3 days, the 4 days, and the 6 days. So we're going to begin to divide. Now remember when you're finding LCM and it's 3 numbers, remember what I taught you. Share and pair. Now the only number that will divide 3, 4, and 6 evenly is a 1. So if I divide that, I'm going to get 3, 4, and a 6. Can we pair any numbers here? Because again, the only number that can divide them is 1, and we'll be repeating ourselves over and over. So can we pair? The answer is yes. So I could pair the 3 with the 6. So what's going to happen is I'm going to bring down the 4. The 3 and the 6 I can divide by 3. 3 goes into 3 one time, and 3 goes into 6 2 times. I have 4 and 2. Those are my pairs, which means that I'm going to bring down the 1 that is brought down. Let's make it black. And these are my pairs here. And I'm going to divide those by 2. 2 goes into 4 2 times, and 2 goes into 2 one time. And the only number that can divide 1, 2, and 1, because really there's no pairs. Well, the ones are pairs, but I mean if you divide by 1, it's 1. We're going to find our LCM. So let's make our L. So we're doing 1 times 3 is 3. 3 times 2 is 6. 6 times 1 is 6. 6 times 2 is 12. 12 times 1 is 12. So my answer is 12. And that's your answer. I hope you found this lesson helpful. We're in the basic math of GED and we're looking at factors and multiples, and that is with LCM and GCF word problems. If you like the content, please subscribe, share, and comment. I read all your comments and I will reply. I will also leave a 4-question worksheet. Again, these worksheets, I'm not gathering any information. A lot of people don't like to use them because it asks you for a name. You can put in a fake name. It doesn't matter. Just to see that if you understand the concept. And I'm just going to put 4 questions. Have a great day and good luck on your GED exam.